Hi, in this video lecture, we will learn how to solve a very commonly asked interview question based on linked list. And the question is merge two sorted linked list. This particular question is available in several programming platforms like HackerRank as well as in LeetCode. Let's try to read the question and try to understand what exactly we need to do in this particular task. The question says, given pointers to the head of the two sorted linked list, merge them into a single sorted linked list. It says that this particular sentence basically says that we have two linked lists in this particular problem and both the lists are sorted and our job is to merge them into a single sorted list. The example specified here, the first list has the elements 1, 3 and 7. You can observe all three elements in arranged order. The second list basically has the elements 1 and 2 which is also arranged, right? So we need to combine the nodes of these two lists such that the merged list also we should have all the elements in arranged order, right? While doing this, we are not supposed to create new nodes. Instead, we should just modify the links of these nodes, okay, such that the overall nodes are combined into one. So how do we basically do this? It's just by modifying the links. So you will be first comparing the first element of the first list with the first element of the second list. Whichever is smaller, you will have a third pointer which will be basically pointing to the smaller of these two things. So it will point here, right? Then what you do is you basically compare this element with this element because we have already considered this. We considered this, right? So between these two, what we do is we again check out which is smaller. This is smaller. So I'll make the link of this refer to this place, right? Then I'll be comparing this 3 with 2, right? And then since 2 is lesser, I need to make the link of this refer to this. Then after this, there's no further elements in this. So I just need to make the link of this refer to this place. Okay. And then going further, you can just observe that all these elements in this list are already sorted. Okay, right. Now, it also tells you a word of caution, or you can also consider the boundary cases. It basically says that either head pointer may be null, meaning that the corresponding list is empty. So it is perfectly valid where one of the list might not have any nodes, or it might also be possible that both the lists might not have any nodes at all, right? And your job in this particular task is to complete a function, and the function name is merge list. That will basically have two pointers or two parameters, and both the parameters are basically pointer of type single linked list node, wherein the pointer head A will basically refer to the head of the first list, and head B a reference to the head of the list of second one list. And what are we supposed to return? We are supposed to return a pointer, okay, of type single linked list node, which should be a reference to the head of the merged list. A reference, if you're working on C, we can consider this a pointer. You don't need to bother about the input format here because we will not be writing the code for reading out this particular portion. Our job is only to complete this function merge list. Okay, so everything else is already provided. The main function, everything is provided. You don't need to bother about it. You just need to write the code for this particular task. Okay. Now, first I'll try to solve this particular program into another platform. Then I will try to take that code, submit it out here. While doing that, we'll try to understand in detail, okay, how things function out there. And I will be using Microsoft Visual Studio to perform this particular task. In this particular program, I've already created the snippets which consist of the structure, which is the same as what was specified in the HackerRank. Plus, I've already written the code for insert node at tail. There's a separate video explaining every single statement of this particular function. You can watch that. The link will be given in the description section. And I also have the display function to display the elements of the list, right? Your job is to complete this merge list. And I've created two lists with the elements like 137 and 12, which is given in the problem statement. Okay, as of now, I've not yet completed this. So I'd like to run this program and see what will be the output of the first list and the second list out here. Here, if you can just observe carefully, the first list has the elements like 1, 3, and 7. You can just see out here, it has 1, 3, and 7 here, right? Now, this is the head, or you can say the address of the first node, okay, which is referred by head 1. Now, this is the address of second node, which is basically, okay, stored in the next part of the first node. And the same way, this is the address of the third node, which is referred in the next portion of the second node. And the next portion of the third node is null. The same way out here for the second list also. As I said, we need to modify the links. Okay, so we'll try to write the code and then we'll try to see the changes happening out here at every step. Fine. Okay. Now, first let's basically consider the case where the list could be empty. Either one of the list could be empty or both the lists could be empty, right? So for that, first I need to take care of that particular condition. If head 1 equal to null, okay, and head 2 equal to null. So if both the lists are empty, what are we supposed to return? Null, right? But if both the lists are not empty, only if the first list is empty, second list is not empty, in that case, I need to return head 2, okay? If head 2 equal to null, in that case, return head 1, okay? In fact, this particular code will take care of this also. Like, so if you just write, assume that both the lists are empty, and if I don't check this, and if I just say, if head 1 equal to null, return head 2. Remember what is head 2 in this particular case? If both the lists are empty, null, right? The same case, if head 2 is null, and assume head 1 is also null, so in that case, we will be returning again null. So if you want, you can basically remove this one, because if both the lists are empty, is taken care by these two, okay, code snippets. Fine. Okay. Now, if the lists are non-empty, so in that particular case, I need to basically create one more pointer, which is going to point to the first node of the merged list. So first, what should be the real type of that pointer? It will be a pointer to a single linked list node, and we can give any meaningful name for this. I'll just try to call it as head3 and initially set it to null. Okay, but where should it point to? So I need to basically compare the first element of the first list and the first element of second list. But how do I compare that? I'll try to compare that by using head 1 of data, right? And if that is lesser when compared to head 2 of data, okay, so in that particular case, what should we do? I'll try to write head 3 should point to head 1. Otherwise, you can refer to head 2. Okay, this is done. Now, head 3 will basically point to either head 1 or head 2, let's first node of the first list or the first node of the second list. Fine. Yeah, you can also write like based on what we understood by solving the problem. So when we had 1 and 1, so since they're equal, we're basically pointing to the first node. So in that particular case, you can just try to write less than or equal to. But if you write only less than, it's going to refer to this particular point. Okay, both at the end, you will see 1 and 1. Okay, it doesn't matter which one is coming from which place. Fine. But we also saw that in case if it basically points to the first nodes, okay, or the first list. So in that particular case, the head 1 should be updated to point to second node. So for that, I'll try to write head 1 equal to head 1 of next. Okay. But in case if head 3 points to the first node of second list, so in that particular case, I need to update this head 2 to point to second node of the second list. Okay, so this particular code snippet will basically make sure that the head 3 basically points to the first of the smaller of two, okay, elements of the list, and then the corresponding, okay, head pointers are updated. Head 1 is updated or head 2 is updated. Okay, so this we have basically taken care. After that, what we should do out here is, yeah, head 3 should always be pointing at the beginning of the completed list, okay, or merged list, but we also require one more pointer to traversing. Okay, like where exactly is this merged once we need to basically, okay, so for that, so I'll try to use one more pointer out here. I can use that as a pointer to current, okay, pointer to current node, which will basically point to head 3, right? So head 3 can be pointing to head 1 or head 2. And okay, so we can just observe this. And after that, we continue the process of comparing the data which is referred by head 1 pointer and head 2 pointer, as long as there are some nodes in both the list, right? So for that, we'll try to write a loop while head 1 is not equal to null and head 2 is not equal to null, right? Okay. Now, what do we do with this? Here, we compare the data. We are only comparing if both the pointers are pointing to the nodes, meaning if there are nodes present in both the list, right? If there are nodes present in both the list, so I would like to compare head 1 of data if it is less than head 2 of data. So in that particular case, I will try to say your PC is pointer current basically refers to head 3 right here. Now I will try to make the pointer current nodes next refer to head 1 in this particular case, and then I need to update head 1, right? Plus we need to also update this pointer current. Okay, right. Else, very similar code out here. We'll try to write pointer current point to the second wherever head 2 is pointing to, and we'll try to update this pointer, and anyhow pointer current should be updated. As we can see, this particular statement is present here as well as here. If you want, you can move this statement outside the if else. Okay, because if it has to be executed in the if part and the else part, why do we need to repeat? We can just put it outside the if else. Now this particular loop will repeat as long as you have elements present in both the list. If you reach the end of one of the list, so in that particular case, what you do it is we come out of the loop. So if you have reached the end of the first list, meaning if the head 1 pointer is null, so in that particular case, I will just say pointer current of next should point to head 2, the non-empty list. Otherwise, okay, that should basically point to equal to head 1, right? So that's the code, and it's always recommended to have braces even if there is one statement. And finally, we need to return the pointer to the merge list, which is head 3, not pointer to current. Pointer to current is used to update the pointers out there. Okay, so now I'd like to call this and try to see that if this particular thing is doing my task. So here I could observe this program out here that yes, I did have 1, then again 1, then 2, then 3, then we can see 7. So I could see that yes, I got the expected results out here. And let us also try to look at the addresses. This head was pointing to 220, this is pointing to 2C0, and whereas this head 3 is pointing to 220, meaning it was basically pointing to this. It basically pointed to this. From here, it pointed to this. Then what happened? We compared this 3 and this 1, and then we saw that this 1 is lesser. So now what we did is this one, instead of pointing to this where the 3 is, this one was changed to point to this node. So what is the address of this node, which is 2C0? So this was basically pointing to 2C0, but remember 2C0 is the address of this node. C80 is the address of this second node out here, 2 there. Then after that, what happened? We compared this and this. So this one continues to point to C80, and then 2's link part. You can just observe, okay, we did not have any further nodes. This portion was referring to this node, and the address of this node was F50, this particular link which is pointing out here, right? That is the address of this node. Okay, so it's going to refer to this. You can just observe here. Fine. And then going further, everything is same. If you wanted to understand more detail about how the pointers are updated, you can always debug the program here. So I have set a breakpoint. After setting a breakpoint, I'll try to start the debugging. I don't want to look into this simple insert at the tail and everything. So that is already done. Displaying everything is already done out there. So you can just see it is already done. Okay. Now what you can do out here is in the watch window, we can basically try to have the required variables. I'll say head 1, head 2, head 3 pointed to current. Okay. Right. Now I'll try to step into the function F11 for that. Okay. Now, as of now, the parameters are not initialized. So let's get inside this. And you could observe the values out here. Okay. So head 1 has a data part to 1. Head 2 has a data part as 1. Head 3 as of now it's pointing nowhere. Okay. Head 3 is pointing nowhere. Fine. You can always have a look out here. You can just observe. Head 1's the address is 970. Okay. And head 2 is pointing to 830 and the data part is 1 and 1. Head 3 is null. Pointing to current, as of now, it's not yet set. It has some garbage address as of now. Fine. So I want to check out this. If the list is empty, no, the list is not empty. Second is also not empty. Now head 3 is set to null. Yes. I'll just check out between 1 and 1, which one is lesser. Okay, and since it is less than or equal to, so since it is equal, I'll try to come to this place. Head 3 will point to head 1. Head 3 will point to head 1. Head 1 is pointing to 970. So you can just observe, okay, head 3 pointed to 970. And now head 1 will point to the second node of the first list, okay, which had a data part as 3. So you can just observe the data part is, okay, head 1 is pointing to 3, head 2 is still pointing to 1, and head 3 basically has the data part as 1, right? Okay. Now, after that, what I'll try to do it is, since I cannot update head 3 because I require that to return, so I will also be using one more pointer called as pointer to current, okay, which will basically point to the same place where head 3 is pointing. And then I do have nodes in both because head 1 is pointing to 3, head 2 is pointing to 1. I'll again compare. I'll be comparing the data 3 and then 1. 3 is less than 1. No, it comes here. Now, in this particular case, P current of next. So this one, as of now, we can just observe one of link is pointing to the next node. The next node's data is 3. So now instead of referring to this 3 out here, it will refer to this changes out here. If you can just observe, the data part is 1. The next part is basically pointed to the next node, which has the data part is 3. This gets changed. This basically will be changed to point to this head 2. It's going to refer to this one. Okay. So let's have a look out here. So you can just observe we have data part is 1 and the next part is also pointing to 1 out here. So now head 2 will basically point to the next node. The next node is 2 there. So you can just see 3 and 2, right? Now again, I will try to update this P current. Now P current will not be pointing to the 1. It will be pointing to 2 now. Sorry, the 1 of the second list, right? Now again, there are nodes in both. So I'll try to compare here. Is 3 less than 2? No, 3 is not less than 2, right? So I'll come to the else part and I'll update this out here. Link of 2 should be pointing to the next portion of that 2, which is null, right? Okay, now head 2 is updated to null and this also gets updated out here. Now it points to 2. Now if I try to check out here, are both the pointers pointing to nodes? No, because head 1 is pointing to a node which has data, but whereas head 2 has already gone for null. So in this particular case, I will come out of the loop. Okay, is head 1 null? No, head 1 is not null. So I try to come to this place. Now the next part of this, wherever okay, P current is 2, the link of the node which consists of data value 2, this one should point to this 3. So you can just observe this one. I'll make it point to 3. Now if we just start from this place, head 3. So head 3 is pointing to 1 and then that next part is pointing to again 1, that is pointing to 2 and that is pointing to 3 and that is pointing to 7. So if you can just observe, I did get this head 3, right? 1, 1, 2, 3, 7. Okay, so I got the required one. But remember, head 3 is pointing to 1. Head P current was moving forward. Okay, so I should not return P current. I should return head 3. I should return head 3 out here. Okay, Now I'm trying to display this to understand that if it is properly present or not. And all these addresses, whatever I printed, is only for the understanding purpose. Fine. Now I'd like to take this particular code and then I'll try to submit in the HackerRank platform. So let me try to take this code, this portion. I'll take this up and let me try to submit. Okay. So after submitting it, after pasting it, I'll try to run this and check out if it is passing the test cases. Yes, it is passing the test cases. And then I'll try to submit this particular code. And yes, if I basically wanted to work with this particular lead code, then you need to modify the name of the parameters, right? Or the data type of this. Like for example, I try to take this particular same code snippet, whatever I wrote, I'm just pasting it out here. And remember, the type here is not single linked list node. It is this one. So I try to take this portion and the names of this, I'll just try to change it to head 1 and head 2. Okay, this I'm changing to head 1, head 2. I cannot change the data type name. So I'll try to take this one. I could have used type def also there, but I'll try to take the same thing here, try to put out the same thing out here, right? And that's it. The logic remains the same. The logic remains the same. No changes in the logic. So I'll try to run this particular program here. Let's see in the meantime, is it submitted? Yes. Okay, the hacker rank. Yes, we have passed all the test cases here, right? The same code. And we'll see if, okay. So here, there is again a little bit of issue out here. The issue out here is the data part is not called as data out there. It is called as val. So I need to change this. I cannot go and modify the data structure out there, like what is given in the line number 3, 4, that I cannot change. So here I need to modify that. The same way, I need to modify this here, right? The next part is called as next itself. It is passed the sample test cases. Now let me try to submit this. Right? So you can just observe the logic was same, but only thing is your name of the structure variable, okay, as well as the members, that could change. So I hope the concept is clear. I'll be sharing the code in the description section. You can refer to that. Thank you.